Hi friends, hope you enjoyed the previous videos of machine learning. Today in this machine learning concept we are going to discuss about the various metrics by which you can evaluate the machine learning models. Before getting into this, we are going to just start with the model evolution, where we are going to look into the things like precision, recall, F1 measure, accuracy, and area under curve. First, we want to know what is this model evaluation. So in machine learning models, we can say that model is a quality model only if you are going to only if it will be providing some quality predictions. So a machine learning model is only useful as there is quality prediction. So the major objective of us is to create a high quality model with more predictive power. So that is our ultimate goal. So for this, there are various methods for evaluating the performance of the machine learning models. So that we are going to see one by one. So first method which we are going to look into is accuracy. So accuracy we know very well. It is a very well known performance metric which deals with identifying the accurate predictions. So this method, the accuracy metric method, is used to represent the strong classification model from the weak one. So this is how we are going to measure this accuracy. So what it denotes is the total proportion of the absorption that have been correctly predicted. That is what this accuracy is going to provide. So how we can measure this accuracy? So for that there is a formula, that is accuracy is equal to TP plus TN divided by TP plus FP plus TN plus FN. So what is this TP, TN, everything? So we can see one by one. First is the TP. The TP represents the number of true positives. So what does this means? It is the total number of absorptions that belongs to the positive class. Okay, so the true positive is the total number of absorptions that belong to the positive class and that have been predicted correctly. Both things should be there. It should be positive class as well as it must be predicted correctly. Then those things comes under the TP. The second one is the TN, that represents the total number of true negatives. So this is the observation that belong to the negative class and that has been predicted correctly. It's just the opposite of the true positive which we have seen. It is just the negative, the absorption or in the negative class, and they were predicted correctly. Then those things comes under the true negative. The third one is the FP. FP is the false positive. So which is the observation that has been predicted as positive, but it belongs to the negative class. That is the false positive. It seems it is identified as positive, but actually it belongs to the negative class. That is the FP. And the third one is the false negative. It is predicted to be the negative class, but it belongs to the positive class. So these categories you are identifying, and based on that you could be able to calculate the accuracy of the particular model. So these are the observations by which we could be able to identify the accuracy of the machine learning model. So from this process we can see that it is clear that the process of identifying the accuracy is a simpler one. There is not much problem occurring here. Just you are going to calculate the value. So it is much simpler and it is easy to use. But when going to the other side, So when there comes the imbalanced classes, when there are number of some imbalanced classes available, at that time this accuracy, the method which we have seen may not be working or performing well. So this is the only disadvantage in this accuracy. So because of this disadvantage, we are going to move to some other evaluation methods, so which we are going to see one by one. So the next method which we are going to use for the evaluation of the performance of the machine learning model is precision. So what this precision is? Precision, it refers to the proportion of all observations that have been predicted to belong to the positive class and are actually positive. Okay, so here we are considering only those positive things, that is all the observations that have been predicted to belong in the positive class, and those are actually positive. Those things you are going to obtain, that is the precision. Okay, so how we are going to calculate this is using this formula. Precision is equal to TP divided by TP plus FP. So these things we have already seen. TP is the true positive and FP is the false positive. So true positive divided by the combination of all those positive values, true positive plus false positive. This gives the value of the precision. So the precision of the machine learning model, it will be low when the value of this TP plus FP is greater than TP. So if the false positive value is larger and this TP plus FP becomes greater than TP, so the precision will be low. So when this FP goes to 0 or less than 0, then automatically what happens, the TP plus FP value becomes less than TP. So obviously this precision value will be high. So this what this precision will help you is to visualize the reliability of the machine learning model in classifying the model as positive. So this is what you are going to do with this precision. So the second thing which we are going to look into is the recall. So this recall is the ratio between the number of positive samples correctly classified as positives to the number of positive samples. I think it is clear. So it is just the ratio between the number of positive samples correctly classified as positive. So first you are identifying the positive samples identified as positive to the total number of positive samples. So this is the ratio by which you are going to calculate the recall. So it measures the model's ability to detect positive samples. Here we are going to consider only the positive samples. So it will be able to detect the positive samples. So when the highest the recall, the more positive samples will be detected. So this will be working based on this particular formula, that is recall is equal to TP divided by TP plus Fn. So this is the change or the difference between the precision and the recall formula. Precision is this TP plus FP, here it is TP plus Fn. So the value of this recall will be low when this TP plus Fn value is greater than TP, and the value for this recall will be high when this TP plus FP value is less than TP. Okay, so at that time the value of this recall will go high. So here in this diagram you could see how the necessity of this precision and the recall. So what this precision is doing is finding out the selected items or relevant, and what this recall is doing is whether the relevant items are selected. So it is identifying whether all the relevant items are selected. Okay, that is what you are going to identify using this precision and recall. So with this we can move to the next evaluation metric, that is F1 square. So it is the evaluation method in which, or this is one of the most important evaluation metric in machine learning that we want to mention specifically, and it is actually the weighted average of the precision and recall. So that is what mentioned as harmonic mean of the precision and recall. So it is actually the weighted average of precision and recall. So also it can be said as the harmonic mean of the position and recall. So it scores, the F1 score takes both the false positive as well as the false negative into consideration. Okay, because it is going to take both precision and recall. So precision takes the false positive and the recall takes the false negative. So this F1 score is going to consider both the false positive and false negative. So how you are going to identify this F1 score is, you are going to multiply 2 into recall into precision divided by recall plus precision. This is how you will be identifying the F1 score. So as I said, as you are using both recall and precision here, the value considers both the false positive as well as the false negative. So you are going to get a accurate result here. So next we have some smaller methods. We could see one by one quickly. The sensitivity or true positive rate or recall. The recall which we have seen earlier, it can be represented in the two different ways, that is sensitivity or true positive rate. So it says what is the proportion of the positive class got correctly classified. So the formula for this is sensitivity is equal to TP divided by TP plus Fn. So this formula looks similar because the same formula which we have used for the recall. So sensitivity or true positive rate or recall, all the three have the same formula, that is TP divided by TP plus Fn. Next is the false negative rate. So here you are going to identify the proportion of the positive class got incorrectly classified by the classifier. The positive class which are incorrectly classified by the classifier. So those are the false negative. Okay, they are not properly identified as false. So that is false negative. So for that the formula is false negative rate is equal to Fn divided by Tp plus Fn. And the third one is specificity or true negative rate. Specificity or true negative rate, it tells the proportion of the negative class got correctly classified. The previous one, the negative class, but they are not correctly classified. In case of true negative or specificity, it is negative class got correctly classified. So specificity is equal to the formula is Tn divided by Tn plus Fp. So next is false positive rates. This represents the proportion of the negative class got incorrectly classified by the classifier. So here the negative class, but they are not correctly classified by the classifier. So here the formula is 1 divided by specificity, or it can be Fp divided by Tn plus Fp. Next we can move to the another one important model measuring method, that is area under the curve. So it measures the ability of the classifier to distinguish between the classes. So what is the actual use of this is to summarize the receiver operator characteristics curve. So what is this receiver operator characteristics curve or the ROC curve? Is this ROC curve is an evaluation metric which is used for this binary classification problems. So what it does is, it is the probability curve. So this ROC, it is the probability curve that plots the TPR against the FPR. TPR is the true positive rate and FPR is the false positive rate. So you are going to plot these two values in the probability curve. So the higher AUC, the better performance of the model at distinguishing between the positive and the negative class. So when this AUR is higher, it performs, that is the particular method which you are going to, particular model which you are going to distinguish will provide more accurate positive and negative classes. So how this can vary is, if the value of AUC is equal to 1, then it will perfectly distinguish between the positive and the negative class. And when this value is AUC is equal to 0, it just makes everything in the reverse order. That is, it predicts all positive as negative and all negative as positive. When this AUC value lies between 0.1 and 0.5 and 1, and such type of model will be able to produce somewhat accurate results. Okay, so there is a high chance that the classifier will be able to distinguish the positive class values from the negative class values. But when this AUC is equal to 0, or when it goes less than this, then automatically this is not able to distinguish between the positive and the negative class points. These are the various methods which will be useful for evaluating the machine learning models. Hope you have understood this. Thank you for watching.